Okay, so welcome back to another video. We're here with Alan today. We're struggling for space, which is why I'm stood behind this unit. I know it's a bit weird. This is a video just to go over the Alpha hybrid heat pump system. So this actual kit is being installed by one of our trained installers into a customer's home tomorrow. They've bought that product off the website. If you go to the Heatable website, you can get a quote to have one of these installed. But as we've got the product here, you were coming down today, we thought it'd just be a good idea to sort of open it up, show the components, talk you through how it works. You've not seen one of these yet, have you?
Not a hybrid one though.
No.
Not yet.
So you've got a traditional heat pump at your house and you've got a gas boiler.
Yes.
But you have to turn one off to turn the other one on.
Yeah.
So this is essentially that system automated with a smaller heat pump. So just laid it out as it is now. Thought it was quite interesting to see it as it comes. So if you think about if you bought a gas boiler from Heatable now, something like this Alpha E-Tech here, that box is what would arrive at your property with a flue and some fittings. I think what's really interesting about this system is the additional component that's going to take that boiler from a seasonal efficiency of about 90% up to about 160% is this component. And when you think about having an air source heat pump installed in your property, usually you'd be thinking, right, you've got a cylinder, you've got a big air source heat pump, radiators, pipework, all the other stuff, an internal unit that comes with it. This is a compact unit, and given that space is a premium in the UK, I think it's a good solution. So what we're going to do now is we're going to unbox it, we'll talk through it, and you can ask some questions. So this is the two boxes, well there's three boxes that we've actually opened up and unboxed just to show you what's going to come as part of this kit. So this is our air source heat pump. Now in terms of its construction and its design, this is as you would get in a normal property for a traditional air source heat pump. The difference here is this is only rated, its maximum output's 4 kilowatt, but its power demand's 2.5 kilowatt. So when you compare that to something like a traditional 3-bedroom detached property would probably need, depending on the construction, 9 kilowatts, maybe 12 kilowatts to power it. This is a much smaller unit. As a result, not only is it smaller in power, but it's smaller in size, because you've got a, how big's your air source heat pump?
8.
8. And that's pretty big, isn't it? Double the size.
Yeah, it's a bit bigger than this one, yeah.
Yeah. So this is like a bit like if you think about air conditioning, that to me looks like an air conditioning split, doesn't it?
Yeah.
That's essentially what it is. And they work the same way. So like if you didn't know how a heat pump works, essentially it's a fridge in reverse or an air conditioning unit in reverse. So it has compressed gas, it draws air from it, through the unit, and then that air is then converted into heat, or in the case of an air conditioning unit, it's converted into freezing cold air. That heat is then put into liquid. So on the back of this unit here, you've got a flow and a return pipe, and that is what's piped into the system that runs round all your radiators.
Some flexes. Some
flexes, yeah. So part of the kit as well, you get the flexi adapters, and they're actually pre-insulated. And the unit also comes with antifreeze valves. So you don't need to fill this with glycol, which is a chemical that is like antifreeze. Have you got glycol in yours, have you?
No.
You've got antifreeze valves?
It reduces the efficiency, doesn't it?
Yeah, it does.
Glycol.
Yeah. Glycol moves a lot slower, so it reduces the efficiency of the product. This just works on regular heating water. So much like your traditional setup now, this unit needs to be outside. So this is a weather rated UV stable paint. This is designed to be outside your house, and that's something that consumers have got to sort of get their heads around, isn't it? Because in the UK we don't really have air conditioning. Well, some people do, and air source heat pumps are relatively new. They are getting some traction in market, but they're relatively new. So people getting used to seeing something like this might be a bit of a hurdle for them to overcome. This unit, because it's lightweight, it can be wall mounted. So it comes on sort of 2 little L brackets and that'll sit on a wall, or floor mounted. So we've done a couple of these so far, only launched last week, and both of those have been floor mounted. So we just use anti-vibration feet, same as what you've got on yours, isn't it? They'll just sit there and essentially that'll stop the unit from making any noise. So that's the first thing to overcome. The second part of the kit is the gas boiler. So when you think about changing your gas boiler in your property, so obviously originally you were a gas engineer, weren't you? You now sort of explore renewable technologies. You've got an Alpha combi at your property, haven't you?
Yes.
Is that what's running the house now, is it?
So I've got combinations, so sometimes I can use, because I'm testing different things,
Yeah.
so I can use air source heat pump fully if I need to, or if I want to I can put it back onto gas and I can use Alpha. But I have got an Alpha
You've got an Alpha.
doing my heating.
So that Alpha you've got there, so if you bought an Alpha combi boiler off Heatable now and had it installed, that's what you would get. The only difference
Is that exact same boiler then?
The only difference with that unit is it's got a little, it's got an additional PCB, so a control board, and that control board's what controls this unit. And it's got something else, can't remember what it is. Oh yeah, the connection for the Smart Tech controller, the unit down there, that works on Bluetooth. So rather than rather than wiring it in, it's got an additional bit of kit that sits in there for the unit. That's the only difference. I think the pump might be a slightly different pump as well, actually thinking about it.
What about clearances then with this?
So because it's such a small unit, it falls under permissible development rights. So you don't need to get planning permission to have one of these installed. You have got to obey some basic rules. I think it's got to be 2 meters away from your neighbour's nearest habitable window. So that's either a living room or a bedroom. So corner of this unit or top of it, front of it, whatever. From your neighbour, it's got to be 2 meters away. That's the only stipulation. Apart from that, clearances are pretty much minimal. So it's around a foot around the unit all the way.
And what about warranties?
Warranty on the unit, so as standard, if you bought this off a traditional plumber or you bought it yourself and had it installed, you'll get a 5-year warranty on all the components. So 5 years on this, 5 years on that boiler, 5 years on the controller. With Heatable, we do an awful lot of Alpha boilers. We work closely with their factory in Italy, so we get an extended proposition. So a Heatable customer would get a 7-year warranty.
What about servicing then?
Servicing for the product, so gas boiler service, that remains the same. So you'll service your gas boiler every year, as you should be doing anyway, and that'll get done. Obviously with a gas boiler you've got combustion, so you get carbon build up, you get seals that require replacement and more cleaning's required. With an air source heat pump, they're a bit like electric cars really, they're sort of maintenance free. The bits you have to do is just hoover the unit out, check over it, make sure nothing's leaking, make sure your antifreeze valves aren't weeping and all that kind of jazz. Pretty straightforward. We'd expect it would add about £30 onto a service cost. Now Alpha themselves, via us or directly through them, will service this product for you. So it's it's not like you're going to have this product installed and have no one who can service it. The reality is you don't really need to touch this unit. You've just got to look after that gas boiler.
Why would you go for this over just having a gas boiler?
So the reason you would go for it is a couple of things. We'll talk about how it sort of works in a moment, but just to cover it briefly, gas boiler on its own is rated at about 90% for its combined efficiency. So that's the element of doing the hot water and for the space heating, so radiators in your home. Now, what that means in rough sense, I'm sure you understand this obviously, is for every £1 you spend on gas, you get 90p's worth of heat production out of that unit, and 10p goes through the flue and goes out the wall. With a hybrid unit, the space heating element of the production, so like what's going to power your radiators in your home, about 60 to 70% of that is going to get done by this unit. And this unit is 420% efficient at its maximum performance. So when you combine the two together, what that means is you get overall system efficiency will climb from 90% all the way through to the lowest flow temperature this can do, go up to 160%. So that would reduce a customer's carbon or their gas dependency by 60%. Now you are going to buy some electric because heat doesn't come for free, but every 10 pence you spent on electric for this unit, you'd get 40 pence worth of electric essentially for free. Well, 30 pence for free. So people would say, why don't you just have an air source heat? Like, you've got an air source heat pump, haven't you, that just does the property. Yes. Someone would say, well, you don't need the gas boiler, get rid of the gas boiler, just have an air source heat pump. There's a couple of challenges with air source heat pumps, which, you know, people...
Well, I've got a big cylinder as well, haven't I?
You've got a cylinder.
You don't need a big cylinder with this.
You don't need a cylinder with this because the hot water's done by the gas boiler. The difference on your house is you've got fairly big property, you've got 3 exposed elevations, haven't you? So you've got an adjoining wall next door. So you've got 3 walls that are losing heat to the element. Your heat pump needs to work, get your house, your radiators internally. I don't know what you've done with them actually, but essentially your system's been designed and it's to run at 70 degrees.
I've got walls knocked down and radiators missing.
Right, okay. So everyone's wearing coats.
It's work in progress.
Yeah, but you've got your original heating system of a gas boiler is designed to run at 70 degrees. Heat pumps are only really designed to run at like 40 to 55 degrees. Anything above 55 degrees, the efficiency drops from 400% to something like 200%, or even 100%. The reason that doesn't work is gas is about 3 to 4 times cheaper than electric. So you need 400% efficiency just to be in the same place as gas. So the purpose of this unit is it will be cheaper to run. They guarantee that, because when part of the commissioning process is we set up the customer's energy tariff into the unit. So Alpha's servers know you pay 30p for electric and you pay 10p for gas. And it will combine the two to make sure that whatever mix it's using, it will always work at the most efficient setting. So
if this went down to like 250% efficient because temperature outside dropped really low,
yeah,
it'd revert back to gas.
Yeah, so what this would do is, these are 400% efficient at about a flow rate of, I think it's 45 degrees or 50 degrees. The purpose of this system is, if above that flow rate, if your house needs 70 degrees flow rate to heat up, the system knows this efficiency will drop right down. That's where the bulk of the complaints come now from air source heat pumps, is people have them installed and they don't improve either the insulation properties of the building, they reduce the heat loss of the building, or they don't increase the element size of the radiators. So then what happens is the heat pump says, well, you know, if you want 70 degrees flow temperature, I've got to work at half my efficiency, which now makes it twice as expensive to run than a gas boiler.
So as a retrofit, not having to do anything with house at all,
yeah,
you could fit this. It would be more efficient initially,
yeah,
and then later on, if you wanted to, when you're decorating, you could change radiators, and then the bigger the radiators, the lower the flow rate, the more efficient it's all going to be.
100%. So that's the key thing to think about. This is a transitional product. So have one of these installed, brilliant, but you can't really ignore leaving radiators that are 30 years old, that are single panel, that aren't very efficient. At some point you've got to tackle them. Yeah. The more things you do in your property to improve the efficiency, the better this gets. Yeah. So if you change all your radiators for high efficiency output radiators, and we do sell radiators on the site, but obviously we're conscious that everyone's got a budget and there's a cost to all this. Yeah. It's already expensive buying this. The system efficiency will improve, and that's the real sweet spot with the product. Now eventually, once your home's up to a really good standard, so your insulation properties are brilliant, your radiators are all a good size, we can drop the gas boiler, put a slightly bigger heat pump in, and we're there. But if you want to do that tomorrow... But
then you'd still need to put a cylinder in for hot water.
And that's the difference, yeah. So you've got to have space.
You've probably got a gas boiler on wall already.
Yeah.
So you'd just be taking that off and putting another one on the same size, more or less.
Yeah.
And then you've just got this to go outside.
That's the only difference.
No updates in house, no new cylinders, no pipes needed new, or all like that.
No, so it's just a like for like swap. And also with an air source heat pump, you've got a cylinder, you've got the internal unit, and you've also got the external unit. With this, you've just got 2 components. So a really, really good bit of kit. and is a great product. So if you've got a property and you really want an air source heat pump, and you either can't have one because you can't update the property's efficiency, or you haven't got the space to have a 9 kilowatt sort of heat pump outside, you've not got space for a cylinder, or you're concerned that it's going to be too expensive to run, then you know what your current gas bill is because you've got a gas boiler. This is already a high efficiency product, so that should improve depending on the boiler you've got now. Then you add one of these on. This is only ever going to kick in when the algorithm knows it's cheaper to run than just having the gas boiler
What
on.
about this, what people are talking about now with the hydrogen ready?
So hydrogen
ready?
So yeah, so the boiler is hydrogen blend ready. So when you hear like hydrogen ready, it means, it could mean two things. 100% hydrogen burn, which there's only 2 products in development at the moment for that I'm aware of that will do 100% hydrogen. But we went to the hydrogen home, didn't we?
Yeah.
One was Worcester, one was a Baxi. I think Valen might have one actually as well. The more common, what people are reverting to there, or what they're trying to get across with hydrogen blend ready, is the product can burn natural gas with a mix of hydrogen.
Up to 20%.
Up to 20%.
But full hydrogen's likely to be 20, 30 years away maybe?
Full hydrogen at the moment is seen as, yeah. The problem with hydrogen, what we learnt with hydrogen on the day when we did the hydrogen house, there's a myth that the infrastructure can't take hydrogen. It can take hydrogen. The rule is, if gas leaks, hydrogen leaks. And if hydrogen leaks, it's actually a lighter gas, so it'll go out into the atmosphere much quicker than gas would, so it's actually a bit safer. The challenge with hydrogen is the production of hydrogen that's not come from a fossil fuel source. So we get most of our hydrogen now for fertilizers from when we refine oil to get gas, petrol, rubber, whatever we're making out of it. You get hydrogen as a byproduct, that's what comes out. So that's not great. Then you can have hydrogen that's made from a turbine. So you need to power a electrolysis unit. So you separate anode and cathode and you separate hydrogen from oxygen, water. If you power that by renewable sources, that's green hydrogen, that's cool. So you can run hydrogen now, no problems at all. But to produce that is really, really expensive, and we don't really make that much from renewable energy. The other option is you can burn a fossil fuel to power the electrolyzer to produce the hydrogen, but sort of defeating the object.
But it's still going to be a long, long way away.
It's a long, long way.
For now, this would sort of like bring you that solution.
Bridge the gap.
Bridge the gap, yeah.
Yeah, it's like this is a product for. With heat pumps, there's a real challenge with them, which for me personally, anyway. I mean, I would love everyone to have a heat pump because we could fit them, which is brilliant. We'd reduce everyone's carbon emissions, and we'd reduce everyone's energy costs. But it's not that practical to do so. There's a skill set shortage, for a start. There's a massive barrier to entry, which is cost. But the reality is, for the people that could find an engineer that could do it, that could afford to pay for it, it's still got to find a suitable property.
In comparison to a normal heat pump, cylinders, everything else?
So if you looked at a like-for-like job, forget any government grants for a second, we'll come back to that in a second. So to have one of these installed is about £7,500 to £8,500, depending on the house. Fully installed, done through us. A heat pump would be anywhere between £8,000 and £20,000, depending on the system that you went for.
Yeah. Where
heat pumps have an edge at the moment is you can have a heat pump installed with something called the Buzz scheme.
Yeah.
So boiler upgrade scheme. It's a government initiative. I think, from memory, Ben's going to call me out now in the comments, it's a £160 million scheme. And we've only spent in 2 years about £40 million. So we're giving people £5,000 towards the job, £6,000 towards the job, and they still, the take up is low. It's super, super low. I was reading the report yesterday and I can't remember the numbers, so I don't want to quote them in case they're wrong, but it's something like 30% of the overall budget has been taken up. Now there's a consultation coming out on the 21st of March 2023, which is they're going to be reviewing this scheme because it's been discussed and it's been brought up in Parliament that, look, this is a bit of a disaster. We're supposed to be decarbonising. No one's taking the scheme up. So there are rumours, and to me it makes perfect sense, that hybrids are going to be included in that scheme.
Yeah.
Now the reasons for me you would include it is you can reduce every consumer in the UK now who could have one of these systems installed could reduce their gas dependency overnight by up to 60%. The overall system efficiency would get up to 160%. Suitability wise, most people have got space for this unit. You might not like the look of it. If it's on the ground, you can get boxes for them, can't you? Covers.
You've got to be careful with airflow though.
Yeah, so just, maybe don't do that. But you've got to get used to looking at one. But from a simplicity perspective, there's no downtime. So if you have an air source heat pump installed, if you don't have a gas boiler in your house, you had an air source heat pump installed, you probably wouldn't have heating or hot water for 3 days.
In what case?
So you're taking your gas boiler out and putting an air source heat pump in.
Yeah.
You've got downtime, haven't you?
Yes.
Because the install process can take sort of 3 days. Think about this system now. Just put this to one side for a second. You're buying a gas boiler. That boiler goes onto the wall. By the end of the day, you've got heat and hot water, okay? And it's already a really efficient product. That boiler, just on a side note, we love them. Stainless steel heat exchanger, Grundfos pumps in them, really, really good construction. In Italy, this product over here retails for 50% of the cost in Italy because Alpha's brand just isn't as strong in the UK.
How difficult is this to install into the system then? Does it need fancy diverter valves and zone valves?
No. So the way this system works is, imagine this is an external radiator, okay? So you tie it into the existing radiator circuit. Now, if you can do it next to the boiler, that's great. So if your boiler's on an external wall and the unit can go outside, that's the absolute first choice.
Yes.
However, we fit tens of thousands of boilers, and sometimes they're in cupboards, sometimes they're in lofts, sometimes they're on the ground floor, sometimes they're on the first floor, so we can't always guarantee that. But it can go anywhere on the system. So if you imagine you've got a radiator and an external wall, you could technically go back to back with this unit. As long as you get back into the return.
Would you have to get onto primary pipes, use 22?
Yeah, so get onto your primary, you couldn't take it off 15. So go onto your primaries, get onto your return, okay? Then, because it's such low power, because like 2.5 kilowatt power rating, you could actually run this off a plug. Now,
so you don't need DNO then?
You don't need a DNO application. No, so DNO application is your district network operator, isn't it? So if you go above 3.7 kilowatt, you have to apply to the grid to say, can I have this unit installed? And they may say yes or no because the grid demand's at an all-time high. Everyone's got an electric car. Everyone's got electrification in the home. People are using more electricity than ever. So the grid's struggling. With this unit, you don't need that 10 amp or 16 amp, I can't remember what it is. So it's just like having a kettle, essentially. So really, really straightforward to install. The only thing you've got to do is there's a cable that comes from the back of this unit all the way into the boiler. And this is where this system gets really, really interesting. The pump inside the boiler is the pump for the unit. So there's no requirements of an external pump. The boiler controls the flow through this unit and whether it turns it on or turns it off via the boiler itself. Also, in this product, I don't actually know where it is, there's an external weather probe.
It's there.
It's there, hold on. I thought that was a condensed drain. So what that means is, this unit is recording the external temperature. Okay, so let's just say it's 15 degrees outside, and on your smart tech controller, you're calling for 21 degrees. Alpha's system then says, right, we're paying that for electric, we're paying that for gas. We want to grow the internal temperature by 6 degrees. What's the most efficient setting to do that? And it'll probably say...
Could it do a blend of both then as well?
Yeah.
So say like the house needs 6 kilowatts, this can only do 4. could it put 2 in from gas, 4 in from this?
So it'll blend it. So it'll turn this on and say, right, you just get to a flow temperature of 50, stay super efficient, I'll do the heavy lifting from 50 to 65 degrees flow temperature. Once the house is up to speed, the boiler cuts off and it leaves this maintaining it. So what that gets around, if you think about driving on the motorway and you come down the slip road and you've got to get to 70 mile an hour, you use a lot of energy. To do that with a heat pump, that initial ramp.
So a lot of customers have on-off style systems where they're going to switch it on when they want it on. When they come home from work, they want to put the heating on.
Yeah.
They still work perfect. But with my heat pump, I have to have mine on
all the time.
All the time, really. Because if you let it drop too low, it's going to take a long time to get back up to temperature.
Yeah.
So this is going to work more with the mindset of most people.
Yeah, essentially on that Smart Tech controller, the other benefit, by the way, it's Smart Tech, it's an app as well. Now granted, it's an Italian app. Alpha are going to kill me for this. It's very Italian. So it's a bit basic, but it's very functional. Okay. Obviously we've installed a handful of these. We've got 2 on test in properties as well, so we're getting used to the technology. It has setback points. So what it'll say is, right, put your target temperature at 21 degrees. And you don't really put a schedule in. It's a bit like a Nest smart thermostat. It just knows it should be on all the time to maintain that. If it starts to notice the internal temperature drop, it'll just kick that the heat pump just on, just to cycle some warmth round.
It's adjusting flow temperature with the sensor outside, so it's measuring outside temperature, and it's saying, right, at the moment we need 25 degrees going in, or we need 40 degrees going in, and it'll just adjust.
So the government at the moment is spending an enormous amount of money telling people to turn their flow temperatures down, aren't they? So turn your flow temperature down reduces your gas usage, but you've got to adjust it all the time, really, because if the next day you've turned it down, it goes really cold, a bit of a cold snap.
You'd have to turn it up.
You've got to turn it up, or people start to complain the radiators aren't hot and the house isn't warm, whatever. With this unit, it's fully automated, so it's actually reading the external temperature, it knows the internal temperature, and it's constantly adjusting that curve to make sure that you've got the lowest possible flow rate. The lowest possible flow rate means you're using the least amount of energy. And the boiler, this system, Alpha, guarantee it is cheaper to run than just a gas boiler, and in some cases, just an air source heat pump, because it knows the tariff data, it knows the blend, it's got the weather data, it's got the internal data. It's a super clever product that is way ahead of anything else that's on the market, certainly for hybrids. Another benefit, before we came on camera, we were talking about what systems are out there, what other options are there. Bosch have got a system, haven't they? And is it Intergas or Daikin have got one, haven't they?
Daikin's got one, an hybrid system.
Yeah.
They use it. I think they use Intergas boiler.
Intergas boiler. The difference with this system compared to those is this is all one manufacturer. So if you get a fault on the system, you haven't got to get that manufacturer and that manufacturer to tend to see who's at fault. You only ring Alpha and they will come and repair it for you. So that in itself is a real peace of mind. The other absolute benefit for this is if your air source heat pump breaks down, you've got a gas boiler. If your gas boiler breaks down, you've got the air source heat pump. So you're always going to have some heat in the home. It's like having an immersion for your hot water. So something important to note is all the hot water production is going to get done from the combi boiler. There's no way an air source heat pump can do hot water. If it did, it would have to go up to 65 degrees, rapid boil it, and the efficiency would go through the floor. It'd probably go into a minus figure, wouldn't it? So to do that with a normal air source heat pump, you have to have an internal water tank like you've got in your garage.
Yeah.
With a buffer unit and all the rest of it that comes with it. All your hot water production is still going to get done by your gas combi boiler. So you're not going to save any money on hot water production, because that's still being done by the boiler. You can reduce it by using less water, and also you may get a saving because if your existing boiler is only 60-70% efficient, this is 93, I think, rated. So there is still a saving to be made, but if you've already got a 93% efficient boiler and you're going to change it, your hot water is your hot water, you can't do anything about that. And that's just the final note for the product. You can't get these in anything at the moment other than a combi boiler.
One thing to point out as well is that gas boiler is not going to be used as much, so maybe it'll last longer as well.
Yeah, so we tabled this with Alpha because we were saying the usage of the gas boiler is going to drop massively. So why you don't get a longer warranty?
Yeah.
And their argument for that is it will drop massively and the product will live for a lot longer than a standard gas boiler. However, the pump's going to be on for more hours. So there's more wear and tear on the pump because you're likely going to have this unit on for longer. What you're not going to have is as much gas valve use, as much burner use. Fan. And it should be cleaner, shouldn't it? Because it's not using as much gas in its production. So I thought it was a really interesting system. I mean, it's different, isn't it? Like, I'll be super disappointed if the buzz scheme doesn't get updated to include them. It's still a great product. We still get people now who are buying these because they want to be greener, they want to save money on the utilities, and they're investing in the home with this technology, and they're the people that have got the money and will pay for it. We can also finance them, obviously, subject to status, keep compliant. But if the buzz scheme comes in,
be good then.
If it was the £6,000, you'd get it for pretty much the same cost as buying one of them off our website now. If it was even half, it's a long way towards, and actually for the government, we would accelerate our carbon reduction overnight because the take-up would be insane, because it's all the benefits of an air source heat pump with all the security of having a gas boiler. It's like electric cars, isn't it? Like I've got a hybrid because I get back and to on work on electric, and then if I go on the motorway, I've got to go somewhere far. It's cheaper and more efficient to use gas. That's what I do. But I do the bulk of my driving round on electric. Now, for me, a full electric car is not really that viable because I do too much distance, and the charging infrastructure for me personally is quite not there yet. So I think of them, I can akin them to automotive. But yeah, any more questions about it, or you sort of?
No, I think it's definitely a good solution, and I think, like you say, it will suit a lot more people, and it's something that we can do quickly and get into properties. Because
I'm an upskill. If you were an engineer fitting one of these now, would you be phased by installing this? Obviously, you've got to do the training course because you've got to set up that controller. You might have to learn a bit of Italian, but there's no to this to install this, is there? No.
I mean, I've installed 2 air source heat pumps now at my house. And they're easy. There's no to it.
There's nothing to it. No. It's the internal bit that takes time, doesn't it?
The wiring is a little bit of a but for a gas engineer point of view, 2 pipes straight into heating system.
And then they're already, our guys that are installing tens of thousands of boilers a year for us are already installing gas boilers. That's just everyday stuff to them. Where we've got an upskill training program live at the moment with engineers that we're taking to Alpha training centres. I think there's some stuff on socials for it at the moment. The guys are going down doing full upskill days, full training courses, and we've got dedicated support at Alpha as well. Because the interest in these and the uptake has far exceeded our expectation, even without any government support. Because it is a very, very competitive product, and it offers an actual solution to decarbonisation and tabling you and protecting you against energy price rises. So yeah, very good.